I'm Anil Kumar, and in this video we'll try to understand how the characteristics of sine and cosecant x are related. Reciprocal of sine x is cosecant x, right? So let us first draw a sketch for both these functions, and then we'll find the relation. Okay, so this is sine wave. Let us say that is our x-axis, y-axis, right? Now if I have to sketch the cosecant function from here, then what can I do? At zeros, I will have asymptotes, right, for cosecant. So these will be the asymptotes. This is 1, inverse of 1 is 1, reciprocal of 1 is 1, and as the function decreases, reciprocal will increase. If the function is positive, reciprocal will be positive. So the cosecant graph will be kind of like this, right? So from 1 it is going to go down towards negative, and from 1 it is going to go up towards positive, right? What I mean to say is from minus 1, right? That's a correction. So from 1 it goes upwards, and from minus 1 it goes downwards. So we have two graphs here. So we are saying f of x is equals to sine x, and we are saying 1 over f of x, we are saying cosecant x is equals to 1 over f of x, right? Which is reciprocal of sine x. Now in this video, we will try to understand different characteristics and how are they really related with one another, right? So first, let us consider what happens at zeros of sine x, right? So if I have sine x equals to 0, then how is the cosecant x at that particular point? So at these points, we will see that the cosecant x has vertical asymptotes, right? So these zeros of sine x are not in the domain of cosecant x, right? That is one thing you observe. Now, so we will write characteristics of sine x on this side and cosecant x on the left side. Now let us consider the interval 0 to pi by 2. Now this is one way where this is 0, then we have pi, and 2 pi is the time period. Now in between we have maximum at pi by 2 and minimum at 3 pi by 2. Now if you consider the portion where x is between 0 and pi by 2, in that case, what is sine x? In that case, sine x will be, so in that case sine x is positive and increasing, right? So we can write increasing and positive. Is it okay? How about cosecant x? Now in this case, cosecant x is decreasing. You have to see from left to right, correct? So it is decreasing but positive. Is that okay? So that is how they are related. Now if you consider the interval from pi by 2 to pi, so that is to say from pi by 2 to pi, in that case sine x is positive but decreasing, right? So in this interval you find that the sine x is decreasing but positive still, right? As far as the cosecant x is concerned, it increases. Do you see that? From 1 towards infinity. So reciprocal increases. But positive reciprocal is positive. We've already seen what happens at 0. Now let's consider between pi and 3 pi by 2. So in this interval, pi to 3 pi by 2, sine x is what? Sine x is decreasing, right? So as you go from left to right, you have to see it is decreasing and it is negative. As far as cosecant x is concerned, it has to increase, right? Since it is reciprocal. So it does the reverse thing, right? So it's increasing but remains negative, right? Now from 3 pi by 2 to 2 pi, sine x is actually increasing, right? but it is positive. As far as the cosecant x is concerned, it is decreasing from -1 to minus infinity. Do you see that? So it is decreasing and it remains negative. Well, this was negative. It remains negative. So that is how sine x and cosecant x are related. Do you see that? Now, as far as the domain is concerned, domain of sine x is x belongs to real numbers. But as far as the cosecant x is concerned, then domain is x belongs to real numbers, but x is not equal to the zeros of sine x. We'll have vertical asymptotes, which are at 0, plus minus pi, plus minus 2 pi. So in general, we can say n pi, where n belongs to integers. Correct? Now, as far as the range is concerned, sine x has a range which is y belongs to real numbers, but y is between plus and minus 1. So it is between plus and minus 1, correct? As far as the cosecant x is concerned, the range for cosecant x is y belongs to real numbers, but absolute value of y is greater than equal to 1, right? Or you could write y is greater than equal to 1, but less than equal to minus 1. So you could also write like that. Do you understand? So in general, these are good characteristics to relate sine x and its reciprocal function cosecant x. Now, as an exercise, I will appreciate if you could find similar relationships between cos x and its reciprocal secant x. That will help you to understand reciprocal of trigonometric functions better. I hope that helps. Thank you.